Good morning. What a great presentation, Jamie and Brian. It was a great setup, and I have similar themes going on, so it actually fits right in. I'm going to be using a lot of technologies here as I set up here. My name is Kimon Onuma. I'm actually an architect myself, and I started on this BIM journey 25 years ago, starting using BIM, so it's been a long journey for us. And we've evolved over time, and you'll see some of the results of what led us to what I'm going to be presenting today. And sorry, I have to scratch down here and get my power going. So we are going to have an interactive portion of this. Hopefully, if the internet's been I've been testing it, it's been kind of going up and down and disconnecting. So I don't know how well it's going to work, but we're going to try it and see what happens. It's going to happen toward the end of the presentation. And let's see, am I on? I think I am. Okay, ready to go. There we go. So, mine is about breaking silos, building informed platforms. And the key word here is platforms. My view of this is that there's a lot of really interesting things happening in the industry. But traditionally, we've been, and still, there's a lot of silos out there and monoliths of information in silo 1, 2, 3, across different systems, across different organizations that want to communicate with each other. And that's really the roadblock right now. But as we've seen in the previous presentations, the technology is already there. It's almost like we don't even have to talk about the technology anymore. The technology capability is there, but there are issues beyond the technology that limit what we can do. So if we can harness that technology, what is possible to break through these silos, these monoliths that trap information in systems that don't talk to each other, for example, or trap in organizations that can't talk from one to the next. And that's really a challenge. The other thing about platforms is a lot of these solutions, like Jamie talked about, the open sourcing concept of being able to share, you can't think that everything that we're doing is just about us and we're going to create this thing in the center and we're going to be at the center. The center of the universe is lonely. This is from John Roach, who wrote a paper in the NIBS journal and received the 2012 Fiatech SETI Award along with us. Digital silos trap data in one universe, and we need to break out of that. And platforms enable collaboration to build the world, essentially. So we need to break silos, and I'm using this. That's actually interesting because you were just going through the connector in the UK, and this is kind of an old view of it upside down. So how many of you remember this device, this silo? It smelled bad, it didn't work, it was expensive, we had documents attached to it that you had to get to the phone number. And then along came this. This changed our world, right? But this really wasn't the huge innovation. The iPhone and the Androids that came out after that, they weren't just a form change. It was basically a huge shift in the capabilities of that device. In the previous devices, if we put information in them, our phone numbers, and we wanted to buy the next brick, you'd have to basically brick the old phone and buy a new one and somehow transfer your phone numbers over, right? Today, with these devices, not only can we throw them away and get another phone and log into the cloud and get our phone numbers, we do everything else with it, right? We call a Lyft or an Uber, we connect with each other. So our expectations have dramatically changed. So everything about our expectations of the use of technology has changed, except in our industry. We're still shifting over, and as Brian described, William Gibson's view of the future is unevenly spread. It's already here, but it's not spread evenly. So that's what we need to do. It's an opportunity, in other words. How do we use these technologies to find information and act on it? So in my experience, we've been using BIM for 25 years, and we're working with a lot of owners. We've been drawn into owners that ask us to not only help them with their project, but think in terms of the bigger vision. What do we do with our portfolio and our life cycle? How do we connect owners to their projects? Projects are important, but it's a small sliver. As an architect, architects are very focused on project design, construction, deliver. Then operations is another discussion, right? My experience with the U.S. Army Corps of Engineers, this is from 25 years ago. I was sitting with negotiating how many documents are we going to produce? Can we do a half-size set so we have less square footage of documents so our contract would go down? We were kind of tied to the physical form of what we delivered. And I thought back then, it's really not the actual documents, but the information that goes into it. It's really all about the data. We saw that pretty early on. We said, what can we do with the data? We had 3 actually SETI awards over the years. US Coast Guard, this started in 2006 actually, looking at entire portfolios of projects using BIM, but also thinking in terms of how do we connect the needs of the organization, the operational side, to why are we building, should we build or should we not build, like Jamie very well described. How do we decide what to build, and what drives the need for that building? So we went through a whole series of capturing that, what is it, to what gets built in the end. Same thing with the Homeland Security headquarters and then the California community colleges. The other theme here is that the underlying DNA, whether you call it a hospital, a Homeland Security headquarters, a community college, a small building, a small project, a large project, the underlying DNA and the drivers of it is very similar. So don't think in terms of, well, this is about a hospital, this is about an airport. It really is that structure can be quickly shifted to other uses. And as has been presented, Stephen Mulva is going to be talking about this, I believe, too, but our industry, our house is on fire. This is a quote from Brendan Bechtel about where our industry is. So it's a problem and it's an opportunity, I think. So building information modeling. A lot of people think that building information modeling is about the tool or the project. Our tagline is build informed environments. It's really the information part that really excites us. The information and the BIM is just part of that flow, and there's a lot of other tools and ways to get to the information. So in 1984, for example, if you wanted to find a seat on a plane, you had to call your travel agent, get the ticket delivered to you, and today we basically find things on the fly, right? Back to the phone again. Our expectations are this level of capacity, right? Imagine if you had to go and make an airline reservation, had to download a PDF of all the flights that are available today and come back next week and buy a seat. It just wouldn't happen. This real-time flow of data, because of the massive amount of data that's out there, we have to stop thinking in terms of static files or projects or information trapped in a format that is not easily accessible. So AI, we talked a lot about AI this morning as well, too. It's threatening in many ways. We're scared of AI. Things are going to be automated. Look at the ROI that we saw earlier. As an architect, that would scare me to death, right? To think, well, wow, what are we going to do if we get automated? But it's really an opportunity if we move into that space. So with AI, what's really going on here? What happens when we think in terms of machines being faster than us, right? That's a given. They're faster at certain tasks. The ability to count, we've had this limit of how fast we can count things, for example. Machines are really good at counting and layering algorithms on top of that, and the complexity of the industry is exponentially increasing as the need to connect things, different parts of the life cycle together increase. So it's going to be absolutely impossible to solve the challenges we have using the traditional methods. We really have to think in terms of automating and working with machines, as we saw earlier, to automate things, and then interjecting and working as what our capabilities are as humans alongside those machines. That's a given. And if we're afraid of this, yes, we will be overtaken. But if we're sitting in this room learning about what's happening, and if we are proactive, it's a huge opportunity that I think is there. Amazon, how many of you use Amazon? A lot of complex things happening in the background. You order a box of chocolates, it gets delivered. They actually have a patent, Amazon, called predictive ordering or something like that, where they know what you're going to order before you order it. That's where they're heading. They know the patterns, right? They know that it's Valentine's Day, so there's going to need a lot of chocolates. They know that you've ordered certain things, or certain things are on your wish list, or you have a certain demographic. So they start moving product towards you into the warehouses. And you know where this is going, right? There's drones, delivery trucks. Okay, they start pushing products closer and closer to us. So they're predicting what we're going to order. We're seeing this happen, right? They've automated a lot of their process. They become hyper efficient at what they do. So he started here, Jeff Bezos, in 1998, selling books. Today he sells whatever he wants, right? And more. He's basically taken over the world. I don't know if this is good or bad, but that's the reality. So how did he get here? This is a really interesting case study, because in 2002, he had a problem too. He had silos and monoliths of applications. He wanted to scale to take over the world, and he said, we can't do this with the technologies we're using today. We have accounting not being able to talk to marketing, not being able to talk to sales, all having their own data, not being able to cross over each other. So he put out a directive. He said, from this day forward, every department's going to share information with the other department with technologies like web services, which is basically a way to allow you to go from one application and read the data from the next, not having to transform it into the next one. It's basically a live link to get data from each other. And he said, we're going to design this in a way to use it internally, and we're also going to design it in a way that we can externalize it to the outside world, even though we're not going to do it today. So we're building something that we don't know what we're going to do with yet, but he knew that there was a value to building the architecture like that. So being able to get to other data from other sources without having to spend a lot of money to transform and translate and move it over to the next system is of huge value. And that they built a whole infrastructure around that to break this, oops, I'm going backwards, to break those silos and use what today is their tools like Amazon Web Services that is also exposed to the outside world as a platform that other applications are built on top of. Many of the solutions that you see in the exhibit hall or that we use in our phones are built on this platform, Lyft and Airbnb. You don't have to build it from scratch. That's the other thing about platform. You don't have to start from zero, and it's become much, much easier to build solutions, even if you're not very technical. The tools are getting easier. We're all turning into software companies in a way, or developers or data experts. But it's not as difficult as it used to be. You don't have to start from scratch. You can actually get there much, much quicker. You're building on the capabilities of others. So another good example of this is the Department of Defense. So in 1983, Korean Airlines flight 007 strayed into Soviet airspace and was shot down. They basically lost the direction of where they were going because they didn't know where they were in space. At that same time, the Department of Defense had a global positioning system used only for defense purposes. Ronald Reagan said, we're going to open up a DoD system to the world, even to our adversaries, because it's for the better for everybody to be able to find a location. And today, every single one of us is using this technology to find a way around, to locate where we are, to find our rides, all that. So this open sourcing of information, this is a very interesting example because this is a Department of Defense system that was opened up to the world to use. And a lot of the technologies in our mobile devices are relying directly on this. So, case study. We worked recently on a Department of Defense project with the DoD and Department of Veterans Affairs for healthcare. They have 200 million square feet. They had problems finding information. They still do, but we're getting much better at this, and I'll open this up later. They have documents, they have digital files, they have PDFs. How do we design hospitals? How do we build them? They had a knowledge base of why do we build these kind of hospitals. They hire consultants to say, how do we design a perfect operating room? Jamie gave some great examples there too. There's all this knowledge that's traditionally trapped in PDF documents. And they shared information by literally, this is up till about 3 or 4 years ago, by burning it on a CD and mailing it to their stakeholders, their consultants. $100,000 each time they burned a CD and mailed it, distributed, because it was such a wide distribution. The minute you burn that CD, the information's out of date. It's like burning a CD of airline schedules. Things change, therefore how can you rely on it? So we told them, we went back to that global positioning system. We said, you as a DoD have a precedent for sharing information, so we recommend you go back to the source data, find out what you have, open it up, and distribute it to the world with no restrictions, because this is how you design hospitals. There's nothing secret about what is the best practice for designing an operating room. Once you put that operating room in Afghanistan, yes, it's a whole different story. It's the same data and a different use. But the fact of how you put together that hospital should be open sourced. And this is a movement that's very important. We need to understand that because we've been used to thinking of monolithic applications, we put our data in the application and we put a big bubble around it and protect everything inside there. But if we break it down into small pieces, then you can decide who gets access to what and how do we share it and how can we use it and how do we open it up to others. So and this is not that long ago, and it's still happening like this in many projects, but as an architect, I'm very embarrassed when I walk into a room like this, and we still use paper too. Paper is not obsolete, but not knowing information about what an existing building is or what you call a certain department Just the naming and numbering of things is a constant struggle to get just to the base level to start a planning and design process. And they have a lot of assets. All of this equipment drives the need for space, and obviously they're servicing their customers, their patients. So all this is just a container. The building is just a container that services what they do. But not knowing what goes into an operating room and what things we're having problems with was a huge problem. So these CDs, we said, okay, let's stop doing CDs. Let's open up the server. We helped them design the architecture. We had a discussion with their IT team. And imagine this discussion where we said the IT, Department of Defense, VA, said, well, you have to open up your data. That took a while, right? But they did it. They actually did it. So I'll play a short video here to show you the results of that. Hopefully the audio works here. Let's see, we tried this yesterday. This is on the web, so I'm just going to play part of it, and you can watch it on the web as well.
To make sure that our nation's veterans are being provided the right health care at the right time and in the right place, VA and the Defense Health Agency have developed a software tool to assist in planning the facilities they require. This software is called CEPS, the Space and Equipment Planning System. When VA determines that a new construction or renovation project is necessary, VA planners work with the medical staff to determine key requirements for the facility. These requirements are entered into CEPS. CEPS then calculates the appropriate net square footage for each new room. A list of all the room names and the required square footages is provided in the program for design. CEPS also provides the preliminary project room contents for each room, which is a list of the equipment and furnishings which belong in each room. These two pieces of information from CEPS are exported in an electronic file to be used as the basis for the design of the new construction project. To enhance workflow, VA has developed a process to integrate the CEPS project export file with Building Information Modeling, or BIM. BIM is database software that integrates three-dimensional graphics and data to create virtual buildings. It is commonly used by architects and constructors as part of the design and construction process. In the integrated CEPS BIM process, the exported CEPS information used to begin the design is imported into BIM, a visual, relationally accurate graphic interface. By moving away from static documents to conveying information in an intelligent 3D modeling format, errors that can occur between the requirements and their conversion to the graphic formats are greatly reduced. This means that all key stakeholders will be able to communicate and manage the project more efficiently and effectively. Here's how the CEPS BIM process works when a design team begins the layout for a new dental clinic. The VA planner, working with the medical staff, defines the requirements for the clinic. The VA planner enters the requirements into CEPS, which calculates the necessary space and equipment to support the delivery of healthcare. The planner then exports these requirements by choosing the BIM Excel export button in CEPS. The design team takes the Excel file and imports it into BIM software. In a matter of minutes, BIM integrates all of the data and visual elements as the basis for the new design, such as this example for a new dental clinic. This dental clinic BIM Excel file downloaded from CEPS has hundreds of pieces of equipment that are now displayed as 3D models. The design team and the VA are assured that the information being used to create the design is now the same as the CEPS export. Once the information is in BIM, the design team can edit, arrange, track, communicate, and report on the space and equipment as needed. The CEPS program for design and the preliminary project room contents can be tracked through the project development. This gives the design team and the VA the ability to audit the work, guiding the design and technical decisions, and leading to better outcomes.
It runs for a few more minutes, but you can watch that on the web if you're interested. The point of this is that there's a lot of stuff happening in the design and construction process that is very complex. The BIMs can get very detailed, as we all know, and we've done all that, but we identified through a series of these types of projects with owners that if we get back to the owner's source data, they all have some kind of data, whether it's in paper format or Excel files or databases. In this case, they actually had a system that output an Excel file, so we identified that as a first step. Okay, you have Excel data. If we put this on the web, you generate the data, you can output it, and then we started saying how would that get automated to put into a BIM. The second message we said is if you build this, and this is essentially an owner's platform, if you build this in an open way, then other vendors can also tap into this. It's not a single solution. It's basically as you start making your data accessible, others can start using it and bring value back to you as an owner. And that's basically what happened after that. And I'll show you this next as well, too. What I showed earlier in the animation was for a whole project. If they define, okay, we need a 500,000 square foot hospital or a 100,000 square foot clinic, here it comes out of their system, which is basically their knowledge base, that they have their rules. If you have a certain number of patients, you need certain kind of exam rooms. And then there's a second part that says, well, what is a typical standard of a dental exam room? And you can go online and pull down that standard. If they change their standard this morning, they said we need another piece of equipment in their database through the platform that I discussed earlier, it actually sees that and it places it in the room. That's a whole automation process of giving you the typical kit of parts that would go into a building, in this case, a healthcare facility. And now I'm going to try and actually show you this. The internet connection here was kind of up and down earlier, so I don't know if this is going to work, but let's try it. Yep, it's actually working. So this is seps2bim.org, completely public again. Parts of it you have to log in, but there's a lot of stuff that's public. And the parts that we recommended to them to open up, for the technical people out there, along the bottom there are APIs and web services to their data. So as they change their data, you can build applications on top of that. And then along the top, you can go in and say, well, I want to find what a typical classroom looks like this. Or a dental exam room, you can say search. It's kind of like it was set up like a Amazon shopping cart, basically. So I want to look for dental. There's a dental exam room right there, DNTG1. I want one of those. And let's take one of these. So this is manually selecting pieces. There's another part to this process that automatically goes and says, go grab 2 of these and 3 of these and 4 of these. But to show me as a designer what are the typical kit of parts that are needed, it builds up a shopping cart like this, and you can change the values. So it's kind of facing the public in a way that's not very difficult to understand, so you can get to the data. Where in the past it was very difficult to get to this. You'd have to go and collect the CDs and get PDF files and kind of say, okay, what's a typical standard? And you could then go and put your email address in here, and it basically builds up a building information model of those pieces on the fly that can then be pulled into Revit and ArchiCAD, SketchUp, and other tools. So that's kind of the baseline. We'll work through this together later, since we have the connection here. It seems to be working. I think we can try it live. So that exponentially changes the amount of time. We've had architects that said they would take weeks, if not months, to get data into just starting the project. Now, in the first few minutes of a project, as you get access to the actual data, you're building a BIM of the requirements, which still need to be resolved. It's the automation part plus the design that has to work together. Okay. So the vision was they want to manage a portfolio and the life cycle of facilities, and they still are heading in that direction. But with them, we identified that if you start at the very beginning, let's see the type of data you have, and let's identify what you want to do with it in the end. And in the middle, there's going to be a lot of design and construction consultants that are going to be doing their work. If we get the data organized in the beginning, then you can feed it through the process and track individual IDs. We can actually track it down to the piece of equipment level. So if they say we need an operating room, when that operating room makes its way through the design and construction process, it has an ID. From a technology perspective, it's a no-brainer. Tracking a piece of information goes all the way through the design and construction process, then gets delivered in the end to the life cycle and operation side and facility management systems. So the portfolio part, the architecture pretty much looks like this. We mimicked what Amazon did. Okay, we have data. You decouple the data from the applications, because in the old days, and there are still applications out there that basically have the data fused very tightly to the application. You have to buy that application to get to that data and work with that data. The trend is the newer applications and even the older vendors now are shifting over to decouple the data and give direct access to the data, regardless of if you're inside that application. So you can build apps on top of that. So we told them, okay, decouple the data, build what's called a service layer in between, which are the rules of how you get to the data, and then allow apps, including your own in-house apps that you build them on top of this like this, because even their in-house apps, a lot of the in-house government apps are fused together, and they're very expensive to maintain because they've been built over the years, and they're fused together, and the data is trapped in their systems. If you do this, then you can start building your own internal apps on top of that, and then you can encourage the outside world, other vendors to come in and start building applications on top of your services. So we had, the first one actually was Revit, so we were starting to test it with Revit, and we have our own system as well. We've built applications over the years in the cloud that we've been using, so we kind of use that as a catalyst to say, well, here's how it would work. And the Revit models here are actually, when you open up the Revit model, if you open up the element, the component and element in Revit, it would actually have the real data that started off in the VA system the minute you push that button and say, let's build this. And this is just for a few rooms, but the same thing would happen for an entire hospital. We also tested with some vendors that have automation software that can take these rooms and start blocking and stacking, like what you saw what Jamie was doing earlier. That type of capability is starting to come online with other consultants and vendors that are getting more sophisticated in the use of these. And this is SketchUp. They came in. So the trend was interesting. We said, okay, we have this process in place, and the vendors out there got very interested because this is owners' data that they can latch onto and show how their tools can fit into this process. We didn't even have to ask, really. We just said, well, we're doing this, and they started coming and say, we have SketchUp, and we have a 3D warehouse on the web, and we can actually pull data in. This is our app, actually. And then easy-to-use mobile apps as well. So the need to get to very complex data in a simple way is becoming more and more important as these systems and the needs keep growing. And the AECO industry, too, architects, this is Sherlock Smith and Adams, they said they went from weeks or months of converting data now down to minutes in the initial stage, and they still obviously have to design it, but they're using that same approach. So it's really about these platforms. If you think in terms of them as Legos, and you have new types of Legos that come along, you want to be able to plug and play into it and still use the underlying data. And if you have simple, clear rules of how you get to the data, then it actually becomes much, much easier to build on top of. So we're currently in a series of other owners, large agencies, government owners, and private sector as well have come and looked at this and said, okay, we want to replicate this, because the formula is exactly the same. If you strip the data away, regardless of the type of building or type of owner you are, you can start applying it to your needs. And the Department of State actually has very similar needs. They want to improve coordination, share data for the life cycle, improve efficiencies, and support projects for the portfolios of projects that they have. And they have existing systems in place that are challenged, just like we saw earlier with the DoD and VA. I can't show a lot of details yet on this project. This is still evolving, but there's going to be a lot more coming from this. So the result is really, it's an opportunity for us in the industry as an architect, as an engineer, as a builder, as a vendor, to really look at owners' data as a platform and build functionality on top of that. And more important, to be able to collaborate with other like-minded consultants and vendors out there. That's what we're always looking for. It becomes so refreshing to be able to talk the same language and be able to make things much more efficient and spend more time on the creative part. That's the part that's fun, being creative with these solutions and running through the automation to get things done much more quickly and bringing more value to that. So BIM Storm. BIM Storm is something we started in 2008. This was about collaboration. This was 10 years ago, and we've had thousands of participants from around the world. It was about using technologies in the cloud and on the desktop as well to be able to collaborate on projects. And it's evolved over the years as the technologies have evolved, but it was really started kind of like, well, let's open it up to the world. It was even people that might be, companies that might be our competitors, we really didn't care. It's this kind of open source approach to let's share how we can do things because it generates new opportunities for us. This was the first one at LAX. It did 24 hours, and we had millions of square feet of facilities actually programmed and designed to different levels of detail on a city. Kind of like what Jamie was showing, actually. How do we automate that process, but also get collaboration from people around the world just logging in and say, well, we're an engineer, we can give you input on a certain building. So our latest one was called Planes, Trains, and Automobiles. So it was about airports. We had San Jose Airport collaborating with us. They gave us our background. This was not an actual project. That's the other key thing. BIM Storms, we pull it out of an actual contracting environment. because then you can experiment. It's a sandbox, like it started as a research and development project internally for us that we then opened to the world and said, okay, what happens if you start getting anybody in there with whatever solution they have, even if it's sketching on paper, we don't really care, as long as we can get the data and decisions into it to start going through it, a workshop or a charrette to do a design and construction process or into operations. So some of the things we did, we looked at what we did with the DoD and VA healthcare spaces, and we said, okay, we captured these modules of requirements into templates that are driven from data. What would it look like for an airport? It's a different kit of parts, but it's exact same DNA, the exact same engine in the background of how do you capture data in a format that can feed into a lot of different systems, that can push into how big a hold room do we need for a 777 aircraft for a level of service 1, 2, 3, 4, 5, so different size spaces. And if the data is driving from the background, then it's possible to start changing the geometries. The BIM becomes just one of the tools that pulls the data into a format that then you can start using the design with. The data drives everything. So this is not a final product yet, but it's more of a let's start something and see where we can go with this. And this was with a team of architects and engineers that were airport planners. I'm not an airport planner, but we worked with them and actually captured their knowledge, and they worked with us to say, okay, here's how much space you need between a plane, wingtips, for example. And we went through an exercise, let's design a 700,000 square foot terminal with 10 new gates. This was for San Jose. It's actually in their master plan, so we actually used their scenarios and ran through what-if scenario with their data. And then there was another scenario where let's add 2 new gates to an existing terminal. What would that look like? And then we started saying, okay, what about other things like gate scheduling? If we can find planes in real time as they arrive at an airport and see it on our watch, here comes your plane, why can't that data drive into a BIM? There's absolutely no reason why. It's just data that can drive, and you can start color coding an existing terminal by hour to show where circulation might be a problem, where there's more, there's too many international flights are coming into this part of the terminal, and it's becoming very difficult in the morning and the afternoon because it's Southwest Airlines has a lot of flights in the morning, a lot in the afternoon. If you start seeing patterns like this, and that data is obviously constantly changing, that's the other thing that we've seen over the years, that being in the building industry, we think of buildings as being very static. But when you start layering all this other functionality on top of the buildings, even minor, let's do a renovation to this wall, or let's have a convention like this and put this wall up and bring people into the room. Every one of you is a sensor, right? You're saying, I'm sitting in this space and there's 300 people in this room and you need a certain kind of airflow in the room. All of that data becomes very valuable. Now, we have a ton of data in the industry already, and the data companies, the Googles and Amazons and Apples out there just are moving into the space very aggressively, and it's a good thing they are. But if we don't actually help lead that way, we're going to lose that opportunity. They're going to tell the story for us. So it's really up to us in the industry that understand, as an owner, what do we want to do with a building? As a designer, what do we want to do? For us to actually tell that story and build the solutions around that and collaborate. So that's what we did here. We kind of went through these exercises of what would it look through gate scheduling. Then we had cybersecurity experts. In the DoD VA work, too, we had a cybersecurity expert where we actually showed them, okay, if you're a hospital and you have equipment in a hospital, here's how we would hack into it. We had programmers that said, here's how we would hack into your systems to get into your MRI machines. They came to us asking that. What is our risk with hacking into systems? So it's a very interesting dynamic that you want to protect your data and you want to give access to the right people. How do you do that? You don't do that with a monolithic system. You have to kind of break it down into pieces and say who gets access to what data at what point in time. Then you can start telling stories around that. If we're in the early planning phases, then as an owner, I can communicate in an open way to anybody in the world what I think a great operating room should look like. When I actually build that operating room and it's in Afghanistan somewhere, you have to lock that thing down because people are going to start hacking into it. But same data, different point in time. And if we don't differentiate it like that, it's going to be very difficult to secure and make it accessible at the same time. Total cost of ownership was another big deal too, is as we go through this, if we have good information at the beginning of the project and we're running through the design and construction process, then we can track what's the performance of this LED light in the operating room as we're running the facility in a clinic in Washington, D.C. You can use that data to loop it back around. That's the ultimate goal. it doesn't all have to be solved at once, and that's another theme that was talked about in the early sessions too, is that it looks really complex, but if you break it down into pieces, you can actually start solving pieces of it and start connecting the dots with others that have solved other pieces of it too. So total cost of ownership was another team looking at that. Blockchain, there's a group of attorneys that were saying, can we use blockchain, that's used for Bitcoin, but can we use blockchain to define contracts and requirements of how we want to design and construct facilities? Because blockchain can get into this ledger process where you can actually validate information as it's going through the project. So we're experimenting with that. A lot of these kind of use cases are running through the BIM Storm based on the data, in this case the airport, but the same thing would happen with a clinic. So then we went to the National Academy of Sciences at a conference like this, and we said, okay, let's do an exercise with the audience, and let's actually get the audience to submit requests. Imagine you're an owner that wants to submit requests for an airport or a hospital or an office building. It was about a 45-minute session, and 10 minutes of that session we got them to do an input. And then at the CURT conference last month, same thing for 15 minutes. We interacted with the audience, and 57 projects were submitted from different people in the audience. And it kind of looks like this. As they came in, teams from outside the room were looking at the data and then starting to work with it. Teams, or it could be machines too, like what Jamie was showing you. We've actually worked with other vendors that have this capability. If you start seeing stuff coming towards you, you can say, what's the optimal thing to do here? Or maybe this is a horrible idea. It's a train wreck. We don't want to do this. You start seeing that very early on and resolving it with those kit parts that are driven from, this is driven from the audience that we didn't give any instructions on. They weren't, at the National Academy of Sciences, they weren't airport planners. We just said, okay, you need a wide body plane, and you need a hold room, and you need TSA checkpoints. You start giving that kind of a scenario, and they start pulling off the shopping cart of what they thought was there. And this is kind of the result. This is a compressed animation of the team outside of the room doing their work in about 30 minutes with the data that was coming in from the teams in the room. So this is kind of to reinforce the potential of collaboration. If we had more than 10 minutes, imagine if you had an hour or 2 hours or 2 days, the pace of that this can be done is just, it's phenomenal what's possible compared to how it was done in the past in a manual method. This is the actual stack of program that came in, and you'll notice that there's too many baggage claims, the light blues baggage claims. There was too many of them because the audience was submitting stuff. And the planes, we kind of stacked them per gate throughout the day, how many planes are coming in. It's kind of tied to that schedule and thing of how many you need. And you notice some holes in it, but it's the beginning of getting the kit of parts there to be able to do something with this manually as a design team or automated with other tools that would do stuff with the data. This is another exercise with I think this was a healthcare facility, again from the audience, how many exam rooms do we need? And then at the airport planning conference in Denver, actually, Jamie, you were there too, right? This is the same one that we were there together, yeah. So we had the audience there submit. These were actually airport planners, and we, on the fly, we were in Denver and said, okay, let's land it on Denver Airport. We didn't even plan this. We saw these programs coming in, and we ended up building 2 new terminals. This was about a 10-minute exercise there as well, too, along with people outside of the room doing the configuration. So now, we still have some time, so I was going to experiment with that here with you guys. So if you can pull out your devices, your mobile phones, and your laptops. And if this doesn't work, I will just play an animation, but let's see if this works. Okay, so you go to bimstorm.com. And by the way, what we're going to do is we're going to get input from you, and then on April 3rd, I believe, we've already set a webinar. We're going to show the results of what happens here. So we're going to do some configuration afterwards and do some experimenting with it. So if you go to the front page and click on the red button here, click to build a BIM. Let's see if this is actually, if I'm actually on the web here. Yeah, the connection's good right now. It'll take you to this page, and there's different tabs along the top. There are healthcare spaces, office spaces, and educational spaces, and transportation. This is the Amazon model here, right? So if you go to transportation, you can go and say, I want to have 1 narrow-body aircraft. You click on, either type the number in or just click on the box. You want a jetway. You need clear zones between the plane. This was a huge discussion of how much space do we need between the wingtips of a plane. we were working with airport planners. They said, well, it's 20 feet or 25 feet, and we think the FAA says this. There's a lot of confusion about what the standards or regulations are that are constantly changing, and they're in documents that you have to go find, or somebody has to have it in their head. So as soon as we start capturing this logic and rules, then it becomes much easier to start building solutions on top of that, or to give the right kit of parts to the participants that are working on the design process to work through this. So I want to hold room. You can do several of these, and we'll keep this open for, I think we're going to keep this open for a week, this particular exercise. So even if you can't connect right now, if you go home, go ahead and try it. And you can even mix and match. You could say, I got some airport, but I want healthcare spaces in that. You can actually put a clinic in the airport, for example. You can build whatever you want. And these healthcare spaces, this is actually outside of the VA and DoD's system. But we built this to show that we can actually read into their system and build another solution completely off to the side, because if we want to change the rules for a different healthcare owner, then you can use the same starting point. And they spent a lot of resources deciding what goes into an operating room. A lot of stuff might still be the wrong assumptions, and we actually found a lot of things that were problems that didn't fit, or the equipment was too big or whatever. But by surfacing it, you start seeing that the train wrecks and problems, you can actually start cleaning up the assumptions. So you start putting this in and saying how many spaces you want. Then you hit next, and you'll get to this cart here. And in the cart, you can bump things up or down. You want more planes or less planes, and it's automatically updating. It's just data again. It's updating the square footage of these requirements. Now imagine if you had a system on top of this that had intelligence and an AI that said, well, you have this many patients in this part of the world, and we're going to pull this in here and do the configuration and deliver it on the site like Jamie showed. I mean, there's a lot of opportunities here to start connecting the dots with different systems like this. And then you put your email in here, and it'll churn in the background for a few minutes and basically collect the data, build a BIM, send you a link, which you can see as a report, or if you have the right tools, if you're using SketchUp or Revit, for example, you can pull it into Revit, and it'll pull the data from the VA and DoD's healthcare requirements into your model with thousands and thousands, if not millions of data points, actually. When you have a 500,000 square foot hospital with several thousand spaces, it's literally millions of data points, because each piece of equipment has attributes associated with it that says, we want this much electricity going into this piece of equipment, or we need this many air changes in this room. All that type of data that there's absolutely no value added to manually churning through that. But by automating it, again, it helps us to collaborate and work with others and to create new solutions. So this is the result, and then you'll go into your email. And for this exercise, we have it set up so it's actually coming to, there's a group kind of managing the project, so we're getting the results, and we're going to then configure it. That's what's happening in the background for this particular exercise. And let's see what's going on here. If I'm still connected, I should get an email. Yeah, so these emails come in with a link. If you're on a laptop, you'll actually see the graphic of that view. The network might be a little bit slow, because I noticed earlier that when a lot of people are hitting it on the network here, it was kind of going up and down, so you might have mixed results. So you can try it again later if you'd like. But this one actually seemed like it might have worked. Yeah, there we go. So this is a BIM built on the fly from data that was just now submitted. It has a date stamp on it, because it was created right now. So if I come back 3 days from now and go back to this link, it'll say this is 3 days old. It's basically, we call it data rot, right? If you keep things in a format that's not live linked, you have to know that this was created at a certain time, and you need to keep on updating it. So everything in here has the equipment. The design is not complete, but all the kits, the spaces are here. Let's see if any of the airports came in. My email's doesn't seem to be picking up right now. Yeah. So it'll start streaming in. So that kind of, and it's just the very beginning. This is really nothing in terms of, as far as the technology goes. It's very, very simple in many ways, because it's kind of what the owner thinks they want, they have in their system. We said open it up so we can see it. Then there's a lot of other things that can happen with the technologies and solutions that are out there. That's kind of the next step. But having an owner's platform like this open means it makes it easier for us to interact and bring more value back to that owner. And we've seen over and over again, we do a lot of BIM evaluation of the BIMs that come into owners, that If data is not configured correctly, then you can't confirm this is what we needed in the model. Names are slightly different. You're typing in room numbers different ways, or you're putting IDs in different ways. It becomes very difficult to track. But when you start thinking in terms, let's just flow the data in, it becomes much more automatic to start getting into systems like this that can automate the process. Yeah, here we go. We got a lot coming in here. So there's one here. And if you have there's an iPad app, too, that you can see this in 3D and twirl it around. This is all, you're seeing it in 2D here on my screen, but there's actually full 3D models in the background of all the data that is being built. So here's somebody from the audience just submitted this. So keep trying this. You can try this for the rest of the week, and we're going to be assembling this and presenting the results. We're going to collect it all together into several projects and show kind of a scenario of how you would actually go through a planning process with this in the webinar in a few weeks. So there's the bimstorm.com site where the webinar will be on April 3rd. It's free to join. We have some of this exercise material online, so we're collecting a lot of these what-if scenarios, and this is some of the instructions that we've actually used for actual projects. We're basically opening it up and showing how it actually works. So my question, and I know there are people out there, who out there currently has a platform? Someone back there's a few hands going up there. What's your platform? Innate. Oh, you're in the, yeah, we talked earlier. You definitely have a platform because you have the ability for others to link into your data with APIs and web services and connect. So it would be very interesting for me to connect what I just showed here with your platform so I don't have to build what you have. It's that we don't want to reinvent the wheel. And it's just impossible to think of one system doing it all. Who else? Somebody else right there? Yeah, right there in the back. Kahua, of course. Yeah, we talked at another conference. We've talked online as well, too. Who else? Swiss, okay. I don't think we talked before, but you have a booth out there too, right? Anybody else? Right there. Earth. Oh, okay, great. Anybody else? Just shout it out. Huh? Yeah, Synchro, okay, great. Anybody else? Autodesk, of course. Ecosys. So see what's happening, and anybody else? Aviva, okay. And I know that CII OS2 is coming. That's essentially going to be a platform to allow people to connect. And I think as an architect, even if you're not into technology today, information that you have can be a platform. There are even free tools out there to convert data, to put it in a format that you could put it on the web to allow your internal team to collaborate. Like Google Docs, for example, is one example. But there's a lot of other tools, including some in this room, that allow you to take your data and put it into a platform format to allow you to collaborate and link. Because if you're an island and you close things down, it's a little threatening at first to think in terms of opening, but by opening up, you actually exponentially increase the potential of collaboration, the potential to create new types of services. As an architect, I never thought I was going to get here. We never planned to become a software company. We're still architects and softwares and consultants to owners now, but it creates huge new opportunities, and it helps to change the industry and move it forward, because we're absolutely not going to get to the efficiencies that we want with the way that we're doing it today. If nothing else, just think in terms of that. We have incredible value and knowledge, but it's just, in many cases, in the wrong format. And with a little flip, we can start shifting things. And as you saw with the VA and DoD, it was actually a very minor shift. We knew that we couldn't change the whole system, so we went and saw what they had and made recommendations of how to pull some plugs into that. There's a lot more that needs to happen. As we know, government agencies are really challenged with facilities and life cycle, and there's a lot of problems out there. But to be able to solve that, we need to think in terms of like that. How do we build platforms, and how do we think that each one of us, each one of our organizations can be a platform and can link into solutions like this? So it's not, you don't have to be a technology expert, and you also need to be very comfortable about sharing. It's very scary to share your knowledge and your IP and whatever, your secret sauce. But I've found that if you share, the more you share, the more opportunities, like I mentioned earlier. So just think in terms of how can we share, and you can still share and protect. It's not open everything up. You can say, well, here's what I'm going to open up because I want to connect. Other things, yes, there's going to be a lot of stuff that might be secret in the background, just like the satellite thing with the DoD. They opened it up, but they're still using it for defense purposes in different ways. But it's the same underlying system. So there's a few minutes for questions, maybe?
I'd like to thank you. Well, that was just marvelous. Okay, so our questions have come in, and I'm going to tweak one of them because it talks about what it would mean for an oil and gas operator to break down data. But I think let's start with, so the VA was in crisis, and we should never let a good crisis go to waste, right? Because that's when you do have people's full attention, right? But you also had to bring a bunch of people together and help them explore how they were using each other's data and what they were having to do to make use of each other's data. So can you describe those workshops a little bit?
Sure, yeah. And it starts with, it's really not even a technology workshop. It's more of a use case and the user stories. Who are you and what are you trying to do? Okay, what are the roadblocks there? What are the biggest roadblocks? Because those are opportunities.
Right.
The biggest roadblocks that are easiest to solve, that's why we went back to the very beginning. It started with this idea, well, we want to manage the whole life cycle. We want to do everything. We want systems that can do everything. And we want all these features. And you almost have like a Chinese laundry list of 300 things that you want to do. None of it will happen if you don't start simple. And that's a big shift that's happened now with these technologies. You can actually start with small pieces.
Right.
So the discussions are always about, what are you trying to do? What are you trying to get your data to that person? Okay, let's find out specifically what that is, and let's figure out how to make that happen. And it might still be a paper process maybe in the end, but we're obviously always looking for, okay, there's a technology, or you already have a technology. In many cases, you already have this over here in this other department, you might be able to use that over here. Or with a few tweaks, you can build something new. Or there's a lot of stuff out in the industry. So a lot of our tasks have been to even identify solutions that already exist, which goes back to what Stephen mentioned this morning. Knowing what's out there is really critical, and we're overwhelmed with information, so we need to filter it down and make it simple to get to.
Okay, and so part of what your company brings is awareness of what all is possible, right? And then you bring the people together. Okay, so I'm going to go here, even though it's kind of an interesting question. The idea of beauty in the world and artistry, there tends to be an assumption that automation will yield up utilitarian buildings that are ugly.
Yeah.
How do you bring beauty into an automated design process?
As an architect, I've asked that question as well, so I fully understand that question. And if we let the machines do all the automation, then you can automate really ugly buildings really fast. But if you interact, you can even build some automation to make things beautiful. So my background, I'm Greek, so I look at Greek architecture and the rules, the orders. Basically, all civilization, Western civilization, and architecture is built on top of that.
Absolutely.
So there are certain rules that can be kind of guidelines or maybe even absolute, but then it's up to us to look at that and say, well, that doesn't work. So that's the most exciting part for me, is that as a designer and an architect, if I can use a technology to guide me toward the right direction and look at 1,000 options and say, well, that doesn't make sense, let's go toward here, or let's start over, or whatever, you have that ability to iterate and throw things away much more quickly. I'm presenting at the AIA in a couple months, and this is a constant challenge as an architect and as an AIA member, is that there's a real fear that automation is going to make us obsolete, and it will if we're not more proactive and get right in the middle of that and say, well, here's how we can be part of that. And owners have a huge potential impact of making that change because they're driving the discussion, right? So if the owners realize that they have the power to use their data and demand good design, it's not one or the other.
Right.
But if you let it go, it will become ugly automated buildings.
Okay. And then one last theme, we've talked about the fact that in this organization, we are a little shy on the suppliers of equipment, that's a population that we kind of need to go after. What role have you seen innovators in those kinds of organizations play?
Suppliers of equipment, so example in the VA work, the VA, everything that I showed you about VA, they can't name the equipment because it's a government agency. We want an operating room, and here's this, we want this light fixture, and we want this kind of characteristic. if they declare what they want with that light fixture, then other suppliers can say, well, here's 100 options that we have that meet that need. And we had that actually happen. There's a group called Atania that has an equipment database.
Okay.
Very specific. Here's a Stryker and here's a Siemens, whatever. VA says we need a light. They say, well, here's 100 options. And we actually had it with a web service link. We actually showed their data coming in there. That's one example.
Nice.
The other example is once the VA declares this is what we have, then we had very small vendors come in and say, hey, we manufacture healthcare equipment of this type. Here's our catalog. So they said, we have a catalog of PDFs. And they said, in that PDF, here's where it links to that. So we actually help guide them, either point them in the right direction or actually help them build some solutions that say, now our catalog data can link to this solution. So you get this live link of communication happening. Then as an architect with Atania, for example, I can be looking in on a plan, and I can have a medical planner making decisions on the side with Atania data, and I can start seeing that data flowing into me in Revit or whatever tool I'm using because of the web service link.
Right. So once they do make a decision, you can bring that back.
Once you bring it in. And if you switch the names out here and you say, well, I'm an Uber and I'm a Lyft and I want to find a ride, and all those technologies it's all there.
Right.
It's all there. You just change the names. But there's fear sometimes of exposing too much about equipment data, or there's all that happening too, so it has nothing to do with technology.
Right. But as we talked about, people get over that when the convenience factor is high.
Yes, or when the competitors get ahead.
Or when the competitors get ahead. Now, speaking of competitors, another theme running through our conference here is disruption, and the idea that owners may not be the same owners someday. EPCs may not be the same EPCs. I mean, if you're letting me design an airport, which I think I just did, I think I just submitted my airport design a few minutes ago, what's to prevent others from submitting their airport designs? And are you seeing that changing the players for who's participating with the VA?
Yeah, we actually explored that in the BIM Storm. So instead of having a contract, for example, imagine if you had more of a hackathon competition.
Right.
Who's the best out there?
Yeah.
And we've been talking to owners specifically about that. Can we change the dynamic of contracting to shift it to make it more of a hackathon, open source kind of everybody who comes in, and that filters through the best rise to the top, and the other ones that might fall behind, they would learn and move up. But that's the opportunity that's the risk if we wait. So this is a big fear for me at the AI, and as an architect, I feel that architects have fallen further behind than the builders.
Oh, like architects may not even be needed as much, right? Is that what you're saying?
Well, no, there's a fear of adopting the technologies compared to contractors and the builders. But I think that if we don't become we're almost as an observer waiting for the technologies to come toward us. We have to kind of move more towards that. And if an owner like this says, well, we have some data, we need to aggressively move there, here's our options with that. So these hackathons are used as a way, the BIM Storms are used as a way to encourage collaboration. And they're all public, the BIM Storms are public, but we've pulled a lot of those into actual projects and actually created scenarios like that. Homeland Security Headquarters was actually one of them. We actually went through a hackathon with Secret Service and everybody to say, okay, what do you need in this building? And all of a sudden we have the requirements built up.
Right.
And once they see that, then it creates a lot of, it really creates a lot more value.
Okay, so this was great. My mind is blown. I hope yours is too. Thank you very much for presenting.
Thank you.
This was awesome.
Very much.